So hello, nice to see you here. Yeah, my name is Krzysztof Dyba. I know this is hard to say, but you can say Chris, Christopher, it will be okay for me. And today I will present topic related to acquisition and processing, automatic processing, special data in R using two packages. First is RStack to process, obtain catalogs, stack catalogs. The second is Stera. Who knows Stera? Who uses Stera? Oh, many people. So, yeah. Here you can see the link to the repository. OGH 2025. This is the repository on GitHub, and you can download the first notebook. One RStack Terra. This is Quarton notebook, and of course there is version available in HTML. Yeah. So basically now you can download this notebook, first one, and open in RStudio. Okay, are you ready? Not yet, okay.
Wi-Fi is not that great.
I hope it will work, because it's not good connection. And what is the situation? GitHub? And here is notebook, RStack Terra. Basically, you can download entire repository code, download zip, or click on this document. This icon, download raw file. Code, download zip. Okay. Good. Okay. And now you can open this file in RStudio. And nowadays, if you want to process huge amounts of satellite data, we can use three helpful technologies. First is spatial temporal asset catalogs. Second is cloud optimized GeoTIFFs. And third is virtual file system. Did you hear about these technologies, tools? No. So basically, they are very important, helpful stack. This is the way in which you can organize spatial data, not only satellite, but GIS data. And this is basically catalogs available. You can connect to them, search for data, and then download. The second is cloud optimized GeoTIFFs. And this is like GeoTIFFs, but optimized for processing in cloud environments. Two things are helpful, useful. Here's this streaming. You can select some area, not entire field, but download only data for your area of interest. So not entire file, but only selected one. So not download 1 gigabyte of data, but only like 200 megabytes. And second thing is you can use overviews. If you want to quickly show the data, view the data, you can use a smaller scale. And also it will be faster than downloading data in scale like 10 meters. Yeah, this is the second important thing. And the last one is virtual file system. It's protocol available in GDAL. And basically you can use this in SF, Terra, raster, because that package is based on GDAL. And this is helpful if you want to connect to some services using network connection. One protocol is C-curl. Basically, you don't to download data, only connect and use HTTP range request or some window area of interest, and again, not download whole data, but only that part of your need. And we use the three mentioned technologies in our workflow. First thing we must do is install packages, rstack. Install if you don't have. Later we can load this package, rstack. Maybe we can get some share or something. No. Okay. So rstack is package allows us to search stack catalogs with spatial data, satellite data. This is standard. And you can ask what data is available, what services. And there is one website called Stack Index. On this website, you can check available catalogs of different data, GIS, satellite data. Some are public, some are commercial, some need registration, some don't. Yeah, the name is Stack Index, and you can find different catalogs with data. Stack Index ORG. And during this workshop, we will use one service called Earth Search. It's very popular. You can use Sentinel data, for instance, without registration. And this is example in this workshop, Earth Search. Here is the link, so we can connect using that stat function. Yeah, and we get objects per stack query. And we are now connected to this service, this URL, and we can send two requests, get and post. It depends on the server what type of request is accepted, but we can use get or post. Let's see how it works. Now we want to check what data collections are available on the server. So we send get the request, and we get a response with that collections. Yeah. So we have Sentinel, Beam, Nape, Landsat, Sentinel, different products, different calibration levels. We can use view function to see that object. And this is list. It's not simple, it's listed, but you can show the response from the server. So we have list of list of list, so it's a complex object. So you can expect that it won't be easy to process. If you wanna process list in R, what function we can use? Process lists. The question is, we have list as input. What function in R we can use to process lists, object in elements in lists? Yeah, exactly. And there is example how to use this Lapli. So we wanna print the available collections. As input, we have lists. So the syntax is like that. As I said, this is not simple, not easy. But if you wanna process lists, you should use that laply. Mm-hmm. And important note, you should use this collection. C1, level 2A. Is okay?
Yeah.
Okay. So next important thing, we use that collection with Sentinel data, Sentinel-2 data. So next thing, we should send a request. And in that request, we can define area of interest, boundary box argument, and time range. We can also limit only 5 or 10 or more images. In this example, I choose 5. And let's try. Yeah. And we get available scenes, images for that conditions. So we select collection, boundary box, area of interest, time range, and we get almost 300 images, scenes. As you can see, you have ID and assets. And basically, this is bands, blue, red, green, near, some additional layers. Of course, for every scene, we have also metadata, like cloud cover, date. We can show sample metadata, attributes, instrument, platform, cloud cover, grid code, a PSG code. Yeah, okay. And I said that object is list of lists, very complex. And in that package, RStack package, we have one very nice function called item as SF. And basically, it converts list of leads to data frame. You can view that. And now the structure of this object is so simple. This is simple data frame, not list of lists, but data frame with columns, with attributes, and rows with images. Only 5 because we use that argument limit to 5. And we have data, cloud cover, grid code, platform, centroid.
What does each line represent here? One picture, one subline.
Yeah, exactly. One scene. One scene contains several bands like red, near, blue. Yeah. Every row is one scene. Yeah.
There are limits on how much images you can extract
Basically, you can download all images on the server. Yeah. But to do it, you must fetch. There is separate function fetch because there is some default limit. I don't remember, but you must fetch to download all scenes.
And it needs to be always square. Can it be like irregular shape?
It must be boundary box, so square.
And then later, can you, let's say, crop?
Yeah. You can crop. In Terra, this is not problem. You can download data in square and next crop. This is no problem. Okay. Okay. Any questions?
Like if you want to work on two scenes, if you want to work on two scenes, can we do, or we have to choose only one scene?
No, you can define a bigger boundary box and you get more scenes.
Okay.
And you can, of course, download it.
Okay.
Yeah.
One more thing that you tell that VFG format is good in Terra package, but if you want to use COG, cloud optimized format, can we do this in R?
COD?
Cloud optimized
Yeah.
format.
Yeah, because our features are implemented in GDAL, so Terra is based on GDAL SF, so we can use like stars also. Yeah,
No, I am asking about COG, cloud optimized format.
yeah.
Yeah.
To read data or create data.
To read data.
Yeah, so you can read. In this example, I will show you.
Okay, fine, thank you.
Thank you. Mhm. So in remote sensing, the most important problem is cloud cover. If cloud cover is high, we can see what is bottom, so that scene or image is not useful. And that attribute we can see here, cloud cover, % of cloud cover. So if the value is high, we can skip this image because it's not useful for analysis. And of course, if you send a request to the server,
To the whole image or for your bounding box area?
whole image, entire image. Yeah.
Second. Can we change, please, because
Yeah.
audio is not coming good.
If you can. One, three. 1, 2, 3. 1. Okay. So in the request, you can define that argument with cloud cover and do some basic filtering. Do you see the text on the screen or make it bigger, the font? Do you see the text or not?
Yeah.
Okay. So send that request with cloud cover filtering.
The default is at the longitude and the latitude or just for different numbers?
Uh,
3.5. No, in the query you had.
Oh. There are definite. X minimum, Y minimum.
I figured out that was the minimum and the maximum, but of what? Of which dimension or what is the?
First is X, second is Y.
Yeah,
Is-
the is it longer than that?
Yeah. Yeah, geographic coordinates.
In WGS84 format.
Yeah. Yeah, not metric, but geographic coordinates. Mhm. So see it again. cloud cover attribute. And now is okay, we can use that scenes images to analyze. So in that function, to summary up stack search function, we can use arguments like collection to select collection, Sentinel, Landsat, Modis. It depends on server what data are published on it. Bounding box, area of interest, runtime, limit, how many images we want, and some parameters like cloud cover. When we wanna download some scene, often some images, like smaller images, are available, and we can access them. And from the scene, we have to select one file, exactly that one. And we can plot RGB composition, how that image scene looks like. Where are the clouds of the shape of scene? The black area is NA values. This is from Poland. Yeah. Probably from Poland because I don't remember, but I think I choose Poland. Everything is okay. So we know how to search, how to visualize some data. Now, if we selected some scenes, images, second thing is to download them, and we have several ways to do it. Here's basic way is download entire file to the local disk, and this is one way, but second way better. If we come back to the tools, technologies, we can read about SOCs and virtual file systems. And now we will do that. So now we will use Zycar protocol from DAL. This is implemented in Terra. This chunk of code, we access the URLs, links to the images. I select blue, green, red, near channels, bands, and we get URLs. You can read this in QGIS on different software, but URLs are important to get the data. Here I also wrote code to download images to disk using download file function from R, but we can skip it. The most interesting are SOCs. And if we want to use C protocol from GDAL, we have to add prefix to the URLs. In that way. So we prepare the links. Now we will use Terra package. Because we need to install. Okay.
All the projects there is a
Yeah, it depends because to process online, there must be codes version. Yeah. Data provider must do it. If not, we can use HTTP range request. In that situation, we have to download entire files. Yeah. So if you want to process only selected parts, fragments of images, the source must be provided. Yeah. So let's try. Mm-hmm. The object is created now. I tested if data is loaded into memory, and we get false, 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 false. So we have only connection to the server. We didn't download the data. We have only connection and created this object. If we plot that, we plot only overviews in small resolutions, or we can set window area of interest and not use that raster with that number of rows and columns, but in smaller number, like 500 on 500, 100. Mm-hmm. We get default names like B02, B03, B04, and A. And of course, we can change using that function names. We can change the names of bands channels to blue, green, red, near, but this is optional. Okay.
When I run this for URLs, it's giving stuff.
Yeah, me too. It takes a long time. I don't know why.
It's taking long.
Yeah, maybe many people wanna connect. Yeah. So we can wait, no problem. But everyone has got that problem, or somebody for your works.
Doing the request at the same time, so.
Yeah, we can wait, no problem.
I get a did not determine stack version. 85. And do you know?
I do.
Got them.
Maybe add this.
This first version.
Yeah.
But with which?
But do you have the new version of RStack package, or maybe old one?
I'll check. I just downloaded it.
Because I didn't get that error.
Okay. I'll check it later then.
Maybe did you change the link or something?
No, I didn't change them.
I don't know. For you is okay, or some?
Name 299. Line number 299.
Yeah. Because this is not acceptable, you must add brackets. Because it's optional. Some people prefer numbers, some people prefer names. You can change it. You prefer number. Yeah.
I'm seeing the values, so that's why I was asking. You see, if you look at the minimum values for band 2, 3, and 4, and 8, so that's why I was asking, like, what processes have been done.
I didn't understand you, sorry. I don't understand the question.
No, I mean, like, since we downloaded the Sentinel-2 datasets, so I wanted to understand what was the processes that were done on that data in terms of the radiometric calibration and or atmospheric.
All the pre-processing steps were required. I think it is not required.
Yeah, it's not required. We use the level 2, so this is calibrated, this is reflectance.
Okay, so
We didn't do any calibration.
the reason I was asking, I'm looking at the values, like you've got like a negative 0.2 to 1.76. That's why I was asking.
A negative pixel value.
Yeah,
In the
in the summary. Because if you like,
This is normal. We have this is outliers, and we have to delete or mask. Yeah.
okay,
This is the level 2. So this is prepared to analyze this. But sometimes situation is like that. We have the outliers values below 0 or above 1, because the range of reflectance is from 0 to 1. So,
yeah, that's why I was asking.
okay. Yeah. Sorry, I didn't understand. Okay. Yeah.
I'm trying to understand the format, this cloud optimized GeoTIFF. So my question is, so if I understand well, you said that if the provider of the information upload a cloud optimized GeoTIFF, you can do some process in the cloud. Is that right?
Yeah, you can request to fragment of the image, not entire image, but we will do in these lines.
Yeah, so okay, so you can do some request of a small window
Smaller area.
just to speed up maybe some process.
Exactly. Because the data will be smaller, not 1 gigabyte, like 100, for example, megabytes. Yeah.
But and can you do more processes in the cloud with the same request that we are doing there, for example? Any other process or
I don't think
resampling?
so. Maybe Edzer can explain. Using OpenGeoHub, we can use server and do everything in the cloud. Yeah. Using OpenGeoHub.
can actually, express, create an expression, like if you wanted to compute some band index or something like that, and have that compute on the server side and then download the results.
Okay, so in that example, basically what we are doing is like try to visualize the information.
Yeah, we connected to server, and now we will select smaller parts, smaller area, and download only that selected area smaller.
Okay.
Yeah.
Okay.
But if you wanna, another approach is cloud-based, so you can use OpenGeoHub and do everything in the cloud without downloading the data.
In this week from Vito, who will talk about it.
Yeah.
It's also a free service.
In that case, you can do all operation in the cloud and download only the final effect, output.
Ah, okay.
Yeah.
Thank you.
Thank you. So let's try. The input raster is like that. This is whole image, 4 bands. Let's define area of interest using ext function from Terra. Now we must define coordinates in the metric system. This is EPSG 32634. Because satellite images have got that EPSG code. So we must define coordinates in the coordinate system, reference system. Is this working for you? Good. Okay.
Yes, sir.
And the rest is working or not? But did you get some error or waiting to connect?
Just saying you run the current chunk, but when it gets stuck.
Stuck. Maybe connection, internet connection is slow. Yeah. So no hurry. So in this chunk, in this step, we defined smaller area, set the window, special window, and now we can plot. Is there any question?
Just a remark for OpenGeoHub. You have to have an account, and you also need some credits. So processing those. So,
Yeah.
but it's, I think it was. I think the major benefit here is that you don't need any account or
Yeah.
credits.
Yeah. So do you see the difference? Input raster was 10K on 10K. We set the special window, area of interest, and now we have smaller raster, and we plotted it. The spatial resolution is the same, but the extent is smaller. And we have only 3,000 columns and 3,000 rows. Using that spatial window, area of interest. For that extent, we can calculate some basic statistics using the sample. Internet is not the best. We have to wait. Cable is like that. Did you hear about stack catalogs before? Or RStack? No, it's first time.
I think for small area it is very good. But for bigger, for large area, I think it's better to use it.
Like cloud platforms, COG platforms, which I understood. Like for if you are working on a county level or a village level, it's good to use this
Servers.
Yeah.
Yeah, but remember, you have to pay for servers, credits. So
Yeah.
maybe if you has got a good computer with space,
Yeah.
maybe it's better to download. Yeah. But it depends, of course.
But for a small area, it works.
Smaller or different, second option is to use overviews, not 10 on 10 smaller overviews. Like, because the here resolution is 10 meters, but if you use pyramids or overviews, you can use like 15 meters, 100 meters. I'm still waiting.
Yeah. Whereas it is also. Yeah, or even if we do in remote sensing, we need a workstation. It costs huge.
Expensive.
We are using our own laptops. We are processing it. So this is, I think, the main benefit of using this.
Yeah. I think the Wi-Fi probably stopped working because no progress.
Yeah, it is still great.
We have small sample, but it's very long because of Wi-Fi effect.
Because we are all processing in the same.
Yeah.
One more question in between. This is
No, we were waiting. So
so as a users, what is your opinion that should we learn Python or R will be sufficient for large area processing, particularly for satellite data?
yeah,
What is your opinion?
I think R is popular for data spatial analysis, for remote sensing data. We have many different packages, so I think this is okay.
So stick to R only. This is not
Personally, me,
not for as a general opinion. What is your general opinion?
I think the most popular is Python, but R is also nice. This choose choice. If you prefer Python, you can use Python. I think many companies use
I am
Python.
R user.
Yeah.
I don't know Python.
Yeah, so R is okay if you wanna do some processing of satellite data. R will be okay. Yeah, because we have Terra, stars, AirStack. Tomorrow I will talk about SIDS. This is framework, high level of abstractions where we have several functions and we can create workflow from starting to ending, and it's very simple. And you can in results get a classification map using several simple functions. Does somebody finish that step? Because I'm still waiting. You? Okay. Yeah.
With the next jump.
That next chunk of code is not lower to battery.
Just reduce the size.
Yeah, maybe 30%.
Yeah. You asked about that outliers. So the clamp functions is to remove outliers, values below 0 or above 1. So that is clamp function to remove outliers. Can we connect this or no option?
I looked, but they don't have the input. If I give you mine, my recording will be.
Yeah.
I texted them, they will check the Wi-Fi.
So one more question I was in my mind. Like I have a defined boundary. Like if we have a vector boundary with us, which we use for processing remote sensing data. Like if we define our boundary, and another scenario is that we are working on a scene. So is our prediction get affected by defining the boundary? Do you get my question?
Not
No.
exactly.
Okay.
One more.
Okay, so like if I have a defined boundary, like this
With complex
county,
shape.
a complex shape. So I am doing some kind of prediction, machine learning predictions. So if I'm working on a scene, like this area is under one scene, maybe in two scenes.
Okay,
So you have to download 2 scenes.
2 scenes. So my question is that is my prediction differs if I work on scenes or if within the boundary?
If you download 2 scenes, you have to connect them, merge.
Yeah, I have to connect them.
Yeah, and you can do prediction for that area, input area.
Yeah.
Yeah, but you have to download 2 scenes. If the area is on intersection between 2, you must download 2 scenes.
Okay. Okay, I will connect
Because
you
if
later.
you have this is that situation, view area is like here. The black area is no data, so you can
Yeah.
do predictions here. So you
Yeah.
need to fill from different scene.
Okay, thank you.
I don't know. Maybe I should abort this operation because still waiting and no progress. For you, this works. Yeah. So from that function summary, we have a sample with statistics, minimum, maximum, mean, median. As you asked before, we have some values like that below 0. So this is outlier. Here, 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 and here. And of course, we have to deal with it. For example, we can remove or mask this value. 2 options. And in Terra, for that case, we have clamp function. So basically, we remove the values below 0 or above 1. And argument values make that the maximum value will be 1, minimum will be 0. And the output now the minimum in every band, in every channel is 0. The next thing what I wanna show you is basic calculations, raster arithmetic. So for instance, we can calculate the PVI index, vegetation index. You know it. So first we need to define the formula. And to do calculation, there is lab function. The third band is red, fourth is near. Also, we provide this function in fun. And the result is here. And the VI index for this area, that smaller area. And if we have output, of course, we can save it using the write raster function to a disk here. And the output will be saved. It's all we discuss. Yeah, you can ask because the summary. So
basically everything. Sorry. So basically everything happens on the internet. The better the internet connection, the faster everything works, and in the end you can download the data you only have to worry about internet connection so that everything is fast.
Not exactly, because we are connected to server, but if you wanna calculate summary or MDVI index, we must do it on the computer, locally on computer. The data will be downloaded, but only that window which we set. So in this line, we set the smaller window, and after that, everything is did on the computer locally.
Also do it on a class computer.
Yeah.
If you have access to a class computer, you can do that.
Yeah, this workload you can run on the server.
I think the people on the server will explain some of that.
Yeah. One person will be present about OpenGeoHub. This is also works on the server in cloud providers. As you had also this topic 2 years ago, OpenGeoHub.
Right. The idea there is that you don't have to
Yeah, the idea there is that if you do things on the server side, that you don't have to worry about individual tiles, right? But that you specify your problem in terms of an extent, in terms of imagery, image collection, the bands that you're using, and then sort of work from there, saying I have this index I want to compute, and then you reduce the bands to a single number, and then you can do some kind of time series analysis over that index. So that is the usual way, and that the system takes over basically the iteration through all the tiles that are involved. Yeah, that is the same paradigm that Google Earth Engine has introduced 10, 15 years ago, 15, I think, that OpenGeo also follows. So there you kind of get rid of that stack. So we're working now, I think, at the stack at the asset level, right? We're looking at asset, which are files, and we're downloading these files. And then we have to write a script, an R or a Python script, to go through this file. So that's a pattern that many people use because it's nice. It's all controlled. It's all on your computer. You can see what's going on. But it doesn't, it's hard to scale up.
Yeah.
Right? At some stage, it stops, like, this is not practical anymore. And it's also messy because you have all these tiles and you need to, remember where they are and stuff. And although it's completely uninteresting. And there are also, Sentinel-2 tiles overlap partially and so on. All that stuff and so goes away when you say I'm going to work at the image collection level. So that's one level higher, and say there's this collection, there's these tiles, I want to work on that imagery, they're all the same. I just want to do this kind of processes on these data. So that is one thing that OpenGeo then does for you, and you define your processes, you don't define how it's going to be computed. So the server side has some software running that can be on the CDSE, that can be GeoPySpark, because that is something that scales extremely well because it's built on top of Spark. That can be, in some other instance, a stack built from Xarray and Dask or something like that, right? Which we have seen has more problems in extreme scaling. Yeah, but might work for intermediate problems, might work for everyone, right? So, but Xarray and Dask have not, are not technologies that come from the image processing. They're, well, to some extent from the bioimaging and so, but not from Earth observation. So there are some challenges that you have with Xarray and cloud optimized geotiffs and so on, right? You're combining, like, you're kind of combining two cultures, which occasionally clashes here and there. It's interesting.
Thank you. And I want to say that presented workflow is very simple. In practice, it's much more complicated because you have scenes with different coordinate system, different grids, so you have to aggregate everything, connect, merge. So this is not so easy as I shown here.
Can I say something? We got a feedback that the expert Street 5 and 6 Wi-Fi work better, so we can try to connect those. The password is same for anywhere. Yeah, 5 or 6.
One more question.
Yes.
Uh, I'm very curious about them. If you have any experience uploading data to this website Stack Index.
I don't have experience.
Okay. Okay. Yeah,
But you can ask, maybe I will know, or Edzer, did you create some stack catalogs?
I never created stack. You mean the stack browser index?
Yeah. So if any of you have experience in this submit, I'm looking at the website and there is one option that it says submit, and then you can submit the data, the static catalog, or the API, or software, or learning resource. I'm just curious about if you have any experience.
For creating stack catalog, there's 2 versions. There's one static and the dynamic one. Probably if you see the link of the stack, the version 1, that will be a dynamic stack. Normally we use a stack browsers. So stack is a JSON, right? So you create this stack based on all this type, the links of the files in the S3. So you will have a JSON of the assets, all that. So you open this in some URL called stack browsers. So this stack browser will just read these JSONs that you upload in the S3 folder, and it will show all the visualizations and the details of the COG layers. So it's simply just like that there. Yeah.
Thank you.
Have any questions?
We still have time, and my idea was good task, but if internet connection is not operational, it will be very hard. So